Hey, Algebra 1, this is a particular quadratic that I didn't see well represented on YouTube, so I want to make sure that you are comfortable with solving one that ends up as messy as one like this. If I've got 4x squared plus 16x equals 8, before we worry about completing the square, which was today's lesson, we want to get rid of any coefficients to x. How will we do that? Divide by the coefficient, which we know you need to do to every term, leaving me with 1x squared plus 4x being 2. Now we worry about completing the square, which means we add something to both sides, right? How do we know what to add? When we complete the square, we add the b divided by 2 squared, and it'll be the magic component that creates a perfect square perfect square. So the b, right? This is a, well, this is b. So b is 4 in this equation. 4 divided by 2 squared gets added to both. Added. All right? So let's see what happens when I add that. X squared plus 4x plus 4 divided by 2 is 2 squared is 4 equals 2 plus 4, or 6. This can be pretty easily factored. It's a perfect square trinomial. X plus 2 squared. We said this was 6. From here, hopefully you know now what we need to do is write square root to get rid of that. Square root. Now we just have x plus 2. The thing that adds a wrinkle here is we don't know if this is a plus or a minus square root of 6. You have to have this sign here, which means now we have to solve two different versions. We have to solve x plus 2 is positive square root of 6. We'll also need to solve what if x plus 2 is negative square root of 6. All right. So, of course, in this sense, we will be subtracting 2 to get square root of 6 minus 2. And in this case, we'll be subtracting 2 as well. The only difference being negative square root of 6 minus 2. In order to check these, it's easiest to come up with the approximate what is that worth. So find the square root of 6 in a calculator and then subtract 2. This ends up being about 45 hundredths. I'll go to this third significant digit so you can tell. This one, I'm in the negatives already, so it's negative 4 and 45 hundredths. Okay, those are our two possibilities. Should probably use a wavy equal sign. And I wanted to do this one because I didn't see any x's on YouTube coming out to something like this, right? Where you get stuck with this, and I think you would have been hard pressed to know what to do next. It didn't come out as nicely, right? So now we put both of these eventually. I'll just put in one, I'll let you do the other. Put in 0.45 in for x. Okay. This will end up being 0.81 plus 7.2 is maybe 8, right? Because we're going back to the beginning here. We don't want what we did the first time. doesn't get this. Yeah. Pretty good. Fix my 7. All right. That was found by putting in this for x. It comes out to 0.81 plus 7.2, which is 8.01, which, do you think that's close enough to prove that this was pretty accurate, since considering it wasn't approximate? Yeah, I'd say so. So 0.45 checks out. And if you test this one, it actually will check out as well. So we know that in both cases, both 45 hundredths and -4 and 45 hundredths are acceptable values to the x in this case, okay? That's how we solve one like that. By the way, for today, your lesson practice will be A, C, D. Why don't you try E and see how that one is not so wonderful? Let's see if you figure that out. Otherwise, check out example 3 to help you. It's going to be a lot like letter B there. All right?